So now we'll discuss the different formulas, section modulus of different cross sections. So first we have rectangular section. So rectangular section we have depth into breadth, or height into breadth, h into b or d into b. So d is a vertical, b is the horizontal length of the rectangular beam, na is the neutral axis passing from the center. Then the formula for moment of inertia I is bhq by 12, or also bd cube by 12. Then y max, maximum distance from the neutral axis, is half the distance, half the depth, half the height, d by 2 or h by 2. Then section modulus z is z formula is I by y max. I is bd cube by 12, y max is d by 2. Simplifying, we have bd square by 6. Z is base for 6 for the rectangular cross section. Second comes hollow rectangular section. Hollow rectangular section, it means its inside is hollow. So as you can see, the outer depth is capital D, outer breadth is capital B, inner breadth is small b, inner depth is small d, as you can see from the figure. And from the center it is the neutral axis Na. Y max is measured from the neutral axis to extreme fibers, that is y max is always, it is d by 2, capital D by 2. So moment of inertia I is first capital BD cube by 12. So this is the I section of I of the whole outer whole rectangle, minus small bd cube by 12. So minus the inside rectangle, we get the hollow one. So 1 by 2, 1 by 12 is common. We have bd cube by 12 minus small bd cube by 12. We have the I section of the hollow rectangular section. The y max is half the distance, that is d by 2, half the depth, that is d by 2. Section modulus z is I by y max. So I is 1 by 12 bd cube by minus bd cube, y max is d by 2. So 12 divided by 2, we get 6. So 1 by 6 bd cube minus bd cube by whole by d. So the same can be applied for a symmetric I section. Same formula applies to symmetric I section also. Symmetric I section means the above flange and below flange should be same. So D, capital D, capital B, and so small d is the web section of the I, and BB is the total section, flange section. Circular section, third one, solid circular section. So the neutral axis passes from the center. The solid circumference has a diameter d. So y max is half the distance, that is d by 2, half the diameter or just radius. I is pi by 64 d raised to 4 for solid circular section. Y max is d by 2. Z is I by y max, pi by 32 by d cube. For hollow circular section, hollow, that is a pipe. So it has two diameters, outer diameter, inner diameter. Outer diameter is given by capital D. Inner diameter is given by small d. Neutral axis is NA from center, and y max is d by 2. So mass point of inertia I is pi by 64 d raised to 4 minus pi by 64 d raised to 4. So pi by 64 d raised to 4 minus d raised to 4 common. Y max is d by 2. That is pi by 32 d raised to 4 minus d raised to 4 by d. Triangular section. So triangular section with the height h and the width b. The neutral axis passes at 1/3 and 2/3 distance. 1/3 distance from below and 2/3 distance from above. So moment of inertia I is bhk by 36. Y max is 2/3 from h, 2/3 of h. Z is I by y max, so it is bh square by 24. So these were the formulas of section modulus, formulas of different cross sections. Bending moment of beams. So bending moment formula. So first, the cantilever beam with a point load at the free end at the span of the beam as L. So bending moment for cantilever beam with a point load, m equals to capital W, that is the point load, into L. So bending moment for cantilever with the UDL, that is W per meter length, is small w L square by 2. So formula for bending moment m is small w L square by 2. Simply support beam with the UDL with the point load at the center with the span L is m equals to capital W into L by 4. Unit is Newton mm. If load is in Newton, L is in mm. And bending moment for UDL is small with the UDL W per meter length is small w L square by 8. And bending moment at a point load at some point, not the center, W A and B. So W A by B L.